Okay, here's another compound inequality problem where there's two linear inequalities that we need to solve first. So to solve this first one, we can start by adding 3 to both sides, which will isolate the x term. This one, we take the 6 away from both sides, it'll isolate the x term. So this one becomes 17x is bigger than or equal to 21 plus 3 is 24. And this one, 4x is less than 16. So over here now, we'll divide by 17 to cancel out the coefficient of x. And this one, we'll divide both sides by 4 to cancel out the coefficient of x. So now we end up with x is bigger than or equal to 24/17. There's no common factors because 17 is prime. And this one we get x is less than 4. And this is an AND problem. So we've solved each of these linear inequalities. And now we have to see what to do about this AND, the conjunction. That's the intersection of these two solution sets, which means it's this upside down U, the symbol for intersection. That's basically the overlap between these two sets. So we could graph each of these inequalities separately. That's one way to do this. There'll be one line to graph the solution of the first linear inequality. And on another line here, we'll graph the solution of the second linear inequality. And then we can look and see where the overlap is, where we'll put the solution that we're looking for here, this conjunction. Okay, so 24/17, notice that that's a number between 1 and 2. And x is less than 4, well that's x is less than 4, so x is bigger than a number that's between 1 and 2. Let's call this, to make things easy, 24/17. So that's 24/17 on each number line. And you get to specify whatever number you want is a point on the line, so why not 24/17? The other one of interest is larger than that, is 4. This is the number 4 on all 3 number lines. So solving the first linear inequality, x is bigger than or equal to 24/17 means it's to the right. Larger means to the right of 24/17 on the number line, so it goes off that way. And or equal to means we fill in that circle. We're including those points. X is less than 4 now means x is to the left of 4, smaller than 4. So x is over here. Now let's look at the AND, the overlap. What points on the number line satisfy both of these linear inequalities simultaneously? Over here only the second one is satisfied but not the first. Over here the first one is satisfied but not the second. Only in the middle are they both satisfied. So the solution we're looking for are mostly the points between 24/7 and 4. But we include the left end point and not the right one because this point is not part of the second solution set, so it can't be part of the conjunction, the AND, the intersection of these two solutions. There we have the graph of our solution. Translating that into interval notation, it's the closed interval from 24/17, closed on the left and open on the right, up to 4, not including the 4. And in set builder notation, this can be written as the set of all real numbers x such that x is in between 24/17 or equal to and 4. So there we have it. The graph of the solution to this compound inequality is right here, the third line. There's the solution expressed in interval notation, and here it is in set builder notation.